May I request everyone to open your video for initial period, and then we can close it. Yeah, thank you. And we can just discuss about the ongoing sessions, and in case you think that some specific topics are required to be covered. Since we are in the third week, so almost 50% of our syllabus is getting over. So I can take feedback from some of you that whether we should include some. I mean, you may be having the timetable of the entire course. If you think some new topics are to be added as an extra session, we can do that. Or if you have any suggestion or feedback, you can go ahead. I see one raised hand by Tejpal ji. Please go ahead.
Good afternoon, sir. Just one suggestion, sir. Since this whole 5G core architecture is based on service-based architecture, virtualization, softwareization. So before this, if one general session maybe on the virtualization concept, advantage of virtualization, how this gives the flexibility in deployment. Actually, that will help those people who are not having background of that virtualization aspect. So just a suggestion, sir.
Yeah, in fact, we have one session related to network function virtualization. If you look at the timetable, it is there. So I hope whatever you are expecting can get covered.
Sir, actually network functional virtualization is one dimension of whole virtualization. So if we can have a
topic, I think in that topic we'll try to cover all the aspects, because we have perhaps allocated 2 hours for that, and we'll try to cover most of the dimensions possible in that 2 hours. So I think this 36 hours overall is slightly less. And that's why we can have extra session if required. So maybe on virtualization, if I get some industry leaders, I'll try to pitch in. And as an extra class, we can add that.
Right. Thank you.
Thank you, Ji. So maybe Prashant is also here. Prashant, if you have to say anything, PP Singh.
हाँ नमस्ते सर, आवाज आ रही है क्या?
हाँ क्लियर है, क्लियर है।
नमस्कार सर, मेरे लिए तो सर ये बहुत ही अच्छा सेशन है। आप इतने सिंपल वर्ड्स में समझा रहे हैं कि हम लोग का कोई खास बैकग्राउंड मोबाइल का था नहीं, मैं काम नहीं किया था, तो ये बहुत ही मतलब हम लोग को अभी तक तो मोबाइल के बारे में काफी टीसी में सेमिनार और ये सब तो होते रहते हैं, लेकिन वो हम लोग ग्रास्प ठीक से नहीं कर पा रहे थे। लेकिन इतना स्ट्रक्चर्ड वे में जो आपने अभी बताया है, तो काफी चीजें अभी बहुत अच्छे से क्लियर हो रही हैं सर, तो थैंक यू सो मच। वैसे आपका यूट्यूब में हम लोग पहले भी कभी भी कुछ जानना है, जैसे अभी हम लोग स्मॉल सेल्स का पायलट कर रहे थे, कांडला पोर्ट वेस्टर्न जोन में कांडला पोर्ट में हो रहा है स्मॉल सेल, मतलब स्ट्रीट फर्नीचर को यूज करके। तो आपका सब हम लोग रिफर करते रहते हैं जब भी जरूरत पड़ती है। थैंक यू सो मच, और बहुत अच्छा चल रहा है ये कोर्स, बहुत अच्छा है। मुझे तो यही कहना है सर, टेक्निकली अभी मैं बहुत इनपुट नहीं दे पाऊंगा, लेकिन
why I am asking, because some of you are actually doing testing which operators are offering, or they want to showcase, you are going to that event. So you may be having certain curiosity or something in mind that this topic,
तो
whether
मेरा ये पूछना था सर कि स्मॉल सेल्स का तो आगे अभी कवर करेंगे ना, स्ट्रीट फर्नीचर
स्मॉल सेल का स्पेसिफिक सेशन तो नहीं है। व्हाट आई कैन डू, because there is a session on a small cell which I have already created, so I'll share in the group. I mean, people can go through, and in case somebody ask a question or anything, we will. So I have a specific session already recorded and it's available. So I'll be sharing that.
Sure, sir. So that will be enough.
Yeah. Pankaj. Pankaj has raised hand.
Thank you, sir.
Go ahead. आपका माइक म्यूट है पंकज.
Sir, good afternoon, sir. Sir, since I am associated with you from the days of UIDAI itself, just I have been working under you nearly 3 to 4 years earlier, sir.
Okay, Pankaj.
सर मेरा एक सबमिशन था सर सिंस सर सी की क्योंकि हम लोगों का आईटी हम लोगों का सर इसमें टेलीकॉम का कोई बैकग्राउंड ऐसा है नहीं, तो सर मेरा एक दो सबमिशन था कि इसमें जो ये जो 3GPP पे है सर, यदि कुछ एडिशनल, और सर मैंने एक ट्राई का कंसल्टेशन पेपर जस्ट मैंने अभी वो देखा है, तो दैट्स वाई कि और जब मैंने उसे देखा तो उसे मैंने देखा कि मतलब जो भी OEMs हैं तो इसमें जो स्मॉल सेल्स लगेंगे तो उनका वेट है वो 6 to 12 kg के अप्रॉक्स में पड़ता है सर. तो सर ये प्रैक्टिकल पॉइंट ऑफ व्यू से सर, सिंस आई एम टेकिंग केयर ऑफ 5G रोल आउट इन झारखंड इटसेल्फ, तो सर मुझे उस पर्सपेक्टिव में कुछ यदि एडिशनल डॉक्यूमेंट भी यदि आप सर ये प्रोवाइड कर पाए, या और यदि सर कोई एडिशनल सेशंस हो तो वो बेटर रहेगा सर.
ठीक है, योर क्वेश्चन इज आल्सो रिलेटेड टू स्मॉल सेल. So I'll share a session which I have. Go through, and then if you have additional question, just like this, we can have in an open forum, we can have a question answer. So I have few friends from Mizoram also. So if they like to speak something. Mr. Jotha Punia, if you want to say something.
हेलो अशोक कुमार जी.
नमस्कार.
नमस्कार
सर आपका वो हॉलिंग आ रहा है, अगर दो डिवाइस से कनेक्टेड है तो एक बंद कर सकते हैं. अभी माइक म्यूट है सर आपका. सर योर माइक इज म्यूट. मालवीय सर. Malviya sir, your mic is mute. I see your video, but your mic seems to be mute. I think sir disconnect हो गए. Maybe yes, Mr. Jothan Puya, if I am think correctly.
Good afternoon, sir. Good afternoon, everyone. Sir, yes, session is as commented by everyone. It's very, very interesting. But sometimes for me as a technical person also, sometimes it becomes too technical. And since we are not into this telecommunication, it takes time for us to understand sometimes.
So that is perfectly fine. That is perfectly fine. So basically, I mean, so since you are in a state government, I feel so it is important that we have some kind of awareness within the state, so that whenever there is a rollout of 5G in your state, and there may be certain aspect which you will be dealing, in the sense that maybe for OW, etc., or for street furniture usage and all. So at that point of time, you'll be able to appreciate what they are talking about and what you have to do. So it is fine if some aspects are too technical, since we have a variety of participants, in the sense that people are from very, very technical background, people are from research institute like CDOT, and also from the unit. So that's why we have structured in a way that there is something for everyone, and everyone, if somebody want to go more into depth, they can always go through the resources which I'm sharing, which may be technical.
Fine.
So you may be knowing Mr. Lal Machuana.
Sir, I know him well. He used to be our secretary, information and communication technology.
So
yes, sir.
He's my batchmate there in Mizoram. Right.
Yeah. right, sir. He's a very nice person, and indeed, Mizoram has, grows in the forms of in the field of information technology during his secretary's time. He has been in the government of Mizoram for around 5 to 6 years as a secretary.
Yes.
And sir, if this kind of training can be held offline, that will be very quite helpful, because attending online class while attending office is very difficult. Sometimes paying 100% attention on the training field on the training online is not very difficult. So if we can have it online, that will be more helpful than the online system.
So the next batch we can try to keep it offline. The problem with offline is that I can have a batch of 25-30. I may not be able to have a bigger batch, so that is the disadvantage. Otherwise, physical trainings are altogether different. Thank you.
Okay, thank you, sir.
Alvia sir, now we can see you.
Good afternoon.
Good afternoon.
I am not able to attend your classes, but I am seeing your videos. That is very helpful, because I am doing some part of the technology trial here in Pune. So one thing I just want to say that this TSTP document is there. If you can brief out some part of this 15 minutes, 20 minutes, some part, because some of the things are not, very much clear in that. So if you are able to discuss something in that TSTP, then it may help within 15-20 minutes or whatever, if you feel, because our staff can also...
5G TSTP was under preparation.
So it is already out. So it is already released long back, and it is there based on that we are doing testing and all. So if you, there's some of the parts are not very... Yeah, it is a small document, not very big, 8 to 10 pages. So if you can go through and, take this, within 15 minutes or half an hour out of this, syllabus, then it will be helpful to all the staff here. So that may help if you can go through, and in the last lecture or somewhere, if you can accommodate this thing, then it will help us. That's what I want to say.
Sure, sir. I'll look into that. Try and in the meantime, you can just share that document, sir, somehow on WhatsApp.
Yes, definitely. I will share you.
Right. Thank you, sir. So anyone else want to say, or shall we start the session? Anyone willing to share his experience or suggestion or anything? Okay.
अगर अशोक जी एक बात थी कि अगर ऑफलाइन आप करेंगे तो मुझे लगता है कि एक हफ्ते में ये कोर्स कंप्लीट हो जाएगा, isn't it?
6 days 36 hours का है, तो 6 days
I think एक वीक तो स्पेयर कर ही सकते हैं, so we can think of that.
1 week. So actually the next batch we will try to have 1 week copy of the topic and take.
Right, sir.
Actually in 1 week, no. So the first half of the first day goes on inauguration, and last day 1/2 goes for closing. So almost 1 day gets lost. So you only have 4 days. So that's why I can start from Monday and go up to Saturday, so that we have exactly 5 days for training and the rest of the part for other purposes. So perhaps we can do that way.
सर मेरा भी एक रिक्वेस्ट था सर, ये काफी इम्पोर्टेंट टॉपिक है सर, और ऑनलाइन में कभी कभी काफी डिस्ट्रैक्शंस हो जाते हैं, बिकॉज बीइंग इन द ऑफिस
कभी कैन ओपन योर वीडियो
एंड सर नमस्कार, मैं संजय गुप्ता सर, डायरेक्टर कंप्लायंस इन ओडिशा से. My request is that sir, since this is a very important topic and it is quite futuristic also. So my request is, sir, if possible, such kind of courses may be offered offline mode, sir. I mean, rather than online. Because sometimes being in the office, there are so many other distractions, like कोई भी कोई meeting में बुला लिए या कभी कुछ इधर हो गए.
When we are talking now, so I just thought, can we have a hybrid mode of training? That means 1 week will be say physical mode, and before I call you for the 1 week, we can have some online training, and then rest of the training can be physical mode. So both combined would be, I will be able to cover the entire topic and also be physical for at least 5 days.
Sure, sir, sure. You are the best judge, sir. You are the best judge. कि कितना portion offline रखना है, कितना portion online रखना है. This is just only suggestion, sir.
Okay, great. ठीक है. Okay, so let's start. I hope the slide is visible to all of you. Just confirm. Can someone confirm that slide is visible to you?
Yes, sir. Yes, sir. Slide is visible.
Okay. Okay. So today's topic is 5G identities. In fact, we'll be talking about various numbering, addressing, and identification aspect related to 5G. And there is a specific specification in the 3GPP, that is this particular document, TS23.003. I would request that you should Google and try to download, although I have shared on that. That will make you aware that you can download all specification released by 3GPP. And this specification is specifically for numbering, addressing, and identification. So there are various aspects of identity in 5G. I'm trying to cover the major one because this specification itself is a big volume of document. So the key aspects I'll be covering. The rest you can go through in case you feel you understand. So 3 types of identifiers I'll be talking about. The first one is about user equipment, mobile devices or other devices which we may be using. Let me mute those who are. Second type of identifier which I'll talk about is the network identifier. All those networks, be it G node B or be it any other network function. So how do we identify the network? Primarily, I'm talking about the radio network. And then we'll talk about various network function in 5G core. So how do we address that or identify that? So there we call it fully qualified domain name. So they are identified by fully qualified domain name, just like an URL you see on a web browser. Okay, let's start from the UE identifier. Out of the 3 broad categories, the first category being user equipment, that is your mobile device or any kind of device for that matter. So what are those identifiers? What are those identifiers? The first identifier is, we call it SUPI. Just a moment. The first identifier, we call it SUPI. SUPI stands for Subscription Permanent Identifier. So this is a permanent identifier of a mobile device or any 5G device. That is, we call it a permanent subscription identifier. The second type of identifier of a mobile device is SUCI, and SUCI stands for Subscription Concealed Identifier. So it's nothing but a encrypted version of the identifier. So that's why we call it concealed. And then finally, we have GUTI, globally unique identifier, which is used onto the radio network and allocated by AMF, and it is a kind of 80-bit it has got, which we will discuss about. So the three types of UE identifiers we will talk about in this session. In addition, you also have permanent equipment ID, just like your IMEI number of your mobile, many of you may be knowing. So that is permanent equipment identifier. So those identifiers are similar to 4G, 3G. So I'm not covering here, but you can read in this particular document. Now, one by one, we will cover SUPI, SUCI, and GUTI in upcoming slides. So starting with SUPI. Okay, so what is SUPI? What is subscription permanent identifier? So this identifier is allocated to each of the 5G subscriber or 5G device, and this can be of many types. This can be of many times. Up till now, if you talk about 2G, 3G or 4G, we had an identifier which is named as IMSI. Many of you may be knowing. In 5G also, one of the type of SUPI is IMSI. Valid SUPI types may. This is one of the type. So IMSI is there, which was there in 2G, 3G and 4G. What new identifier has come in 5G for the user equipment? The first is Network Access Identifier, NAI. So NAI is nothing but when you write something, some username at the rate, some domain name, so that becomes a network access identifier. So that can also be a permanent identifier in a 5G network. We will talk about this in the upcoming slide. Then there can be GCI. What is GCI? What is GCI? GCI is Global Cable Identifier. In US and all, there are residential gateways, RGs, based on this cable lab specification. So this residential gateway, which is providing broadband, this is deployed in many countries, US I gave example. So this RG can also be part of 5G core network as non-3GPP access, which we discussed yesterday. So the identifier is Global Cable Identifier, which is defined by Cable Lab itself. The same identifier can also be used in 5G. So when you have a fixed network cable residential gateway, we call it CRG. So in that case, the identifier is not IMSI, but it is the GCI, but not straightforward in a NAI format. That means whatever GCI you have at the rate of the domain name from where this RG is coming. Now the next identifier, we call it GLI, Global Line Identifier. So what is Global Line Identifier? Global Line Identifier is also a RG. We call it BRG, Broadband Residential Gateway. And this is based on broadband forum specification. This kind of residential gateways are again popular in the US, in some other part of the country. So these BRGs can also be connected to our 5G core. So what will be the identifier in such cases? It is the GLI, but in NAI format. So these are different kind of permanent identifier of a 5G user equipment. So now we talked about IMSI, then we talked about NAI, GCI and GLI. One by one, let me explain all these in a bit detail. If you have any question, please go ahead. Somebody was trying to speak.
Sir, just one point on this slide.
Yeah, go ahead.
Yeah. So here in the first part, we are saying identifier allocate to each subscriber in the 5G system. So does that means that I have 5 devices and I am one subscriber, that this will be same?
No, I mean, although here it is being said as a subscriber, here it means the SIM in case of a 5G, if you are talking about SIM, every device, user equipment, instead of writing subscriber, the correct word would be the user equipment.
Right.
So now IMSI, I mean, most of you may be knowing. So all friends from DO.
There is a network. Second, after that subscriber identifier, can you please go back to the previous slides?
Yeah, please.
Here, there is a network specific identifier. There is a global cable identifier. These are network identifiers. Here, it is a collection of devices. It is not a single device.
No, these are not collection of devices. This is if you have a residential gateway, right? So residential gateway becomes one user equipment, right? So, and even today, this residential gateway, that particular device or user equipment has got an ID, and it is either GCI in case of a cable lab RG, or it is a GLI, global line identifier, in case of the RG based on this broadband forum.
So it will have a identifier for the cable operator and then for the country.
Yeah, and so basically these identifiers are already defined by Cable Lab in their specification for their RG. Same will be used in 5G for identifying such residential gateway in the 5G network.
It is not present in the 4G network, this type of identifier?
No, because 4G do not parent a non-3GPP access as of now, except Wi-Fi. These are not there. So these specifications were not there in 4G.
Okay, thank you.
Okay, fine.
Sir?
So, yeah, please go ahead.
Sir, if we say this relate with the user equipment, then where this IMEI will come into the picture?
So IMEI is equipment identifier, the hardware identifier, right? And IMSI is a subscription, right? IMSI is your subscription. When you subscribe from a operator, you get IMSI. Whether when you buy a mobile phone, you already have a IMEI number. Got the point?
So in IMEI will be there, na, in 5G also.
So that will continue, right? So those IMEI is already there in mobile devices, that will continue to be there. Those are called permanent equipment identifier, PEI. Those are called PEI. Okay, so now the IMSI. IMSI is International Mobile Subscriber Identity, right? So many of you are from DOT, BSNL, you may be knowing this. So IMSI is a 15-digit identifier. Basically, IMSI is provisioned into the SIM which you buy from an operator, which contains country code, mobile country code, mobile network code, and then you have mobile subscriber identification number. Okay, so let me ask one question. Who allocates mobile country code? Anyone from your side?
ITU.
Very right. So ITU allocates the country code, right? In India, 2 country code is allocated, 404 and 405. And then you have mobile network code. This can be of 2-digit or 3-digit. So who allocates this MNC?
DOT.
In our case, it is DOT. In some countries, the regulator does it. So some government authority will do it. And then about MSIN?
This is with operators.
Yes, very right. So operator can choose up to 10-digit MSIN. Please remember, this is not the mobile number which you have, right? Mobile number is called MS ISDN. That is different thing. That we call it public identifier, right? So this is IMSI. So this is one of the SUPI, one of the type of SUPI. Now the next type of SUPI was this one. NAI I talked about, Network Access Identifier, right? So the NAI format is just like a username at the realm. So we'll talk about with example. And in case it is a private network we call it SNPN, stand alone non-public network. In that case, in addition to mobile country code, mobile network code, there is a network ID issued by the country. So that also becomes part of NAI, or for that matter, for different numbering addressing. In case of a SNPN network, we use NID so that we are able to identify that it is a private network and we'll be able to identify that private network. Now, suppose I'm talking about the RG CRG, cable residential gateway, which comes by cable lab, right? Cable lab specification based CRG. In that case, the identifier is GCI, Global Cable Identifier. So in this case, the
slides are not moving, sir.
I mean, identifier will be like username at the realm or the domain. And how it is defined? It is defined as this. This is 5gc.mnc.mcc.3gppnetwork.org. So that is the PLMN ID we add to above. Example is this. This is an ID. This is an ID. GCI. We talked about GCI, you know. So this is just an example of GCI. So GCI at the rate of 5gc.mnc. MNC you have taken as 12. MCC you have taken as 345.3gppnetwork.org. So this kind of ID will be used by this CRG when it connects to the 5G core. So in place of IMSI, this CRG will offer this as its ID. In case it do not belong to a mobile operator, the PLMN public land mobile network, I mean the operator which is allocated some network code, if it is coming for a purely private network, so there it will be like GCI at the rate any operator xyz.com or operator.com or whatever name it is, right? So both options are, if it is part of a 3GPP network, that means it is coming from a operator who has been allocated an MNC, then it can be represented like this. Otherwise, it can be operator.com, maybe geo.com or maybe xyz.com and all. So this is how. Okay. Now the next example, this example of BRG CRG, just look at in a pictorial form. So if you look at this picture, yesterday I was talking about that there is a concept of 5G residential gateway also. In addition to BRG CRG, there is a concept of 5G residential gateway. So that 5G residential gateway connects to G node B also, and also it connects to core via a wireless access gateway function. So both options are there. So in this case, what will be the identifier? And then the next example is that I have a fixed network RG, wherein fixed network RG, it is a kind of a cable residential gateway or broadband residential gateway, any of that. So common name given is the fixed network RG. So which connects to 5G core via this wireline access gateway function only because it do not have access to connect to Z node B because it do not support 5G radio, right? So how do we, so what are the different identifier? So for, let me erase the ink so that, so basically when it is 5G RG, 5G residential gateway, in that case it can use IMSI because it is part of 5G network and IMSI can be allocated. But if you are using fixed network BRG and CRG, then in that case, normally GLI or GCI in a NAI format will be used. In case this FNRG can support IMSI, then even IMSI can be used. But generally it is GLI and GCI. These are examples which I covered in the previous slide, that how it will look like. So before I proceed, if you have any question till this point. Any question by anyone? Or shall I proceed?
Sir, one of my question is that who is allocating which this element is allocating SUPI to different user equipments in case of mobile or other telecom.
So let me I got your question. So when you take a mobile connection, you are given a SIM. So that SIM is having the IMSI. That SUPI in form of IMSI is actually a subscription. When you buy a SIM, you are getting the IMSI along with your SIM, which is provisioned in the SIM, right? That is one. These residential gateways are also provided by some operators. So when they provision it a permanent identifier also for that RG. You got my point?
But yes, sir, I got the answer. But in case of our 5G, suppose in case of FNCRG or FNRG, so this translation, how they will be doing that? The operator will be doing the translation, or some element in our 5G network will be doing this translation, adding of this extra bit.
Right. So there is no need of translation as such. Whenever BRG or CRG need to be connected, so the two operators will be knowing that BRG is now being connected to 5G network and all. So just like you provision a SIM, suppose when you take a connection, your data is actually provisioned into the UDM. Similarly, when a RG is connected to 5G network, you have to provision that particular RG into 5G network. At that point of time, all configuration, all data would be entered into UDM. You got my point?
Thank you.
Okay.
Sir, just for understanding, IMSI is for device identification. Now, when we are also identifying the residential gateway, the cable gateway, is the use case is that they will be able to feed the video content through this gateway, just like head end, and then distribute to the cable network? Am I right, or there is any other use case?
So basically, suppose at your home you have this residential gateway. It is just like today you have a Wi-Fi broadband connection. No, it is similar, same. You can consider this as the same as your broadband connection or a Wi-Fi network, wherein you are able to connect all your home devices. If you look at my previous picture here, this picture, what you see from FNRG, you are connecting your computer, you are connecting your TV, you are also connecting all the IoT devices which may be at your home. So basically it is providing you some kind of a broadband service, and you are able to connect any number of devices at home. So that is the purpose of such a residential gateway, that all the devices and there may be a Wi-Fi access also. I mean, if it is giving a Ethernet connection, you can always add a Wi-Fi hotspot. So basically you are able to connect even other devices wirelessly within your home. right? So it's a gateway which, so you can do anything with that, right? It is just an kind of a pipe given to you.
And sir, this TV connected to this FNRG, is it internet TV or it is?
Yeah. So basically, FNRG will give you just a broadband, right? Rest of it is the service, right? On top of it, you can have these services.
All are based on broadband.
Yeah. These are just broadband. And in case, suppose this particular TV want to avail a service which is a 5G native service, so that can also be offered just like that can be offered on a mobile. Right?
Right, sir. Got it. This is just counterpart of the mobile UE devices. Where it is standard, and this is a counterpart to bring in these devices in the network. Right.
Correct. Now we will understand the concealed permanent identifier, subscription concealed identifier. So we also call it privacy preserving identifier, because if you use SUPI directly, you are kind of exposing your identity onto the network. So we use this SUCI in place of SUPI, which is a concealed one. And then how we generate SUCI? We just encrypt SUPI. SUPI with some standard scheme, you have to encrypt, and then it becomes SUCI. So basically, there is a public key which is provisioned in your SIM, which will be used to encrypt the SUPI into SUCI whenever required onto the network. And I just said that this public key is provisioned into the SIM during initial configuration itself. Okay.
So this is a public key of the operator.
Yeah. So it's the same concept of public private key, whereas public key is given provisioned in the SIM, and it encrypts using that, and it can be opened only by the operator when it reaches. So basically UDM has the private key. Yesterday I was talking about this only, that UDM actually decrypts. No other network function have this. So UDM decrypts and convert that into SUPI, and then it gives back to the other network function. Okay, so this is the schema how SUCI is made, or what are the different parameter in a SUCI. So the first is the SUPI type. The SUPI type we have understood, it can be IMSI, it can be NAI, or it can be GCI and then GLI. So basically this picture was taken at the time of release 15. At that point of time, this GCI and GLI was not there, only one. So 2 and 3 was added, and rest you can consider as kind of still open. So some more kind of such access can be added to 5G core. Yesterday someone was asking that whether 2G or 3G can also come. So as of now it is these. And then you have a home network identifier. What is home network identifier? It is your mobile country code and mobile network code. And this only in case of IMSI. In case it is NAI, then you already have as part of NAI either at the rate of operator.com or at the rate of 5gc.mnc.mcc.3gpp.org. So you already have some kind of network identifier. Then you have a routing indicator. So there is a routing indicator in the sense that whenever those registration signaling is happening, when SUCI is getting transferred, it also gives the routing indicator, which gives an address of that which AUSF or UDM instance will handle this particular customer. Even in the roaming, suppose you are in the roaming and you are giving SUCI. So the roaming network will not be able to decrypt this SUCI because the key is in the home network of UID of UDM of home network. So it has to communicate with the home network UDM. Their decryption happens, then only the identifier will be known. So the routing indicator is for the purpose of reaching out to the home network UDM and AUSF so that authentication is done. Now here comes the main item of the encryption. So what kind of encryption schemes are being used, right? So there are 2-3 types already defined in the 3GPP specification. The first one is that when we are not using any encryption, there may be an instance that we will not be using the encryption. Then there is a concept called profile A. This is some kind of protection scheme. Profile B, the second type of encryption. So you will identify which encryption you are using so that UDM knows that how to decrypt. If it is profile A, they will have a one way of doing it. If it is profile B, then their algo will be different. And there are certain values which are reserved. And there is also a provision that a proprietary protection scheme can also be deployed. Suppose you want to use it for defense, you want to use it for more security. So you can devise your own protection scheme and use it so that it is not in public. So it becomes more robust, or some new kind of protection scheme is invented that can readily be implemented. So something will come from the standard and some you can use it depending upon the use case. And then you also add the public key ID so that the UDM is able to find out corresponding private key so that it can encrypt. And this is the once you encrypt the whatever value you get, right? So you are only encrypting the MSIN part of IMSI in case it is an IMSI. So only the MSIN part, which can be of 10 digit, is getting encrypted. The rest of the values are going as a unencrypted into the packet. Only the MSIN is encrypted, right? So this is a kind of example how SUCI is created. I'll just give you one example so that you understand better. So let us assume that MCC is 234, MNC is 15, and your MSISN is this, whatever number. So your IMSI will look like this. Your IMSI will look like this. Now the routing indicator given is say 678, and suppose public identifier key is 27. So how do we write the SUCI? So basically, let us start with this. Suppose there is no encryption. I am using the null scheme. In that case, the first value is 0 because it is an IMSI. So 0. Then you have 2, 3, 4 and 15. That is your home network identifier, MCC and MNC. Then you have a routing identifier, this one. Since I am using protection ID 0, so 0. And then since I am using protection ID 0, and then some ID I am using for public key and private key, which is not required because I am using null scheme, so again 0. And then the MSIN, I am just putting it without encryption being a null scheme. There is the one example. Second example is using the encryption. So that example is like this. Just a moment. Sorry. Okay. So here the example is what you see here is so everything is same except you are using a protection ID which was given as 27. And then you are encrypting the MSIN and encrypted value you are putting. And you are also adding something for integrity check. So this become your SUCI in case you are using profile A. Similar will be for profile B. So now in some case your SUCI will also be having NAI format. So how it will look like? Just see this. So NAI format for SUCI. So two aspects. So this will also have this format, username at the realm, just like any other NAI format. And in case it is IMSI as a username, then this realm part is not required because IMSI itself will have MCC and MNC identifier, so it will not have the realm part. Now let us take the example of this. Suppose IMSI is this. Suppose IMSI is this. So that means your country code is this 234. Then 15 becomes your network code, and then this becomes your MSISN. Now if routing indicator given is 678, public key identifier 27, then how NAI will look like? For the null scheme where I'm not using encryption, it will be type 0 because IMSI, then you have MCC, then you have MNC, then you have routing ID, then we are using scheme 0, and then we are having the user ID as same as MSISN. I'll not put at the rate because that is not required. We already have MCC and MNC present, so we can identify which network. If it is profile A, then the only difference is that I have to add the public key and also the encrypted version of MSISN. And we also add something for integrity protection. Now let us take another example, which is not a PLMN. In that case, your user ID will be just like say user17 at example.com, right? And let us assume routing indicator as 678 and public key identifier as 27. In this case, how we will write the NAI format of SUCI? So here will be type 1 because type 0 was IMSI and type 1 was NAI. So type 1, and then I have routing indicator as 678. I'm using a null scheme, so scheme 0. Then the user ID exactly, and realm is also same because I'm not using any protection. In case I use a protection, then what is changing is I have to put this public key also as part of the SUCI, and also I'll have encrypted version of this user 17. This user 17 will get encrypted with the profile, whatever profile we are using, and then @example.com. So this is an example of NAI format for SUCI. Now what about GCI and GLI? It is very, very simple. Just see, since it was type 3, the GCI was type 3. So type 3 and all those numbers we can put. This is a null scheme. And then @5gc or operator.com. The point to note here is that in case of GCI and GLI, we are not encrypting. As per specification as of now, we are not encrypting the GCI and GLI as of now. Similar is for GLI. Now I'll stop here and take any question which you may have till now before I proceed to GUTI. Forum is open for any question.
Sir, one question is that is there any restriction of for the length of the SUPI or SUCI digit restriction?
So restriction is there on the ID itself, no? So IMSI length is fixed. So what is variable in the whole identifier is if you write a NAI format, so user ID is the only variable, rest are already fixed, right? And user ID in case of IMSI is also fixed, 15 digit, right? Only in case of a private network where you are having some user ID. So there also if it is GLI, so GLI standards are already there, GCI standards are already there, right? So, and at the rate realm part, Huawei.com or Airtel.com. So as such, I don't see any requirement of limit anywhere. Everything appears to be already defined. Is that okay?
Yes, sir. In relation to the sir, my another question is that, sir, in case of IoT devices and M2M devices, the same IMSI will be used, sir. Means 13-digit what we are allocating, or separate same will be used, I think, sir. In case of IoT,
so one way of using IoT devices is of course the IMSI. But there appears to be some development going on wherein even some kind of other ID of the device can also be used as identifier. But I'm talking about whatever was done up to release 16. Beyond that, they may include some more ID. For example, in case of other devices, even the MAC ID can become a identifier going forward. But whatever is defined till release 16 is only these: IMSI, NAI, GCI, and GLI. And they still have other options to be added going forward if required. Any more question? Okay, let us talk about GUTI. Or shall we have a break for 5-6 minutes and then we start, if it is okay for all of you?
There is one question from my side.
Yeah, please.
So what about the satellite telephony? Suppose someone is calling from the satellite telephony, then what shape it is going to take?
I didn't get your question. Are you talking about satellite?
Yes, sir. I'm talking about satellite telephony. Suppose someone is talking from the satellite telephony, then what shape it is going to take, sir?
So let me, so I was not able to hear your full question, but what I understand you're talking about satellite. So there is already in release 17 and 18, the 3GPP, they are working on unifying the satellite. So today, no, so the terrestrial network like mobile network is completely different or separate, and satellite networks are completely separate. So now there is a specification which is happening at 3GPP as part of release 17 and also release 18, that how we can unify the satellite communication and also the mobile communication together. So there a lot of other aspect will come out. Did I answer your question or you had something else in mind?
Basically, when you're,
thank you, sir.
Sir, when you're talking of unifying these networks, I think they are talking of how to call from a satellite mobile to this 5G mobile or 4G mobile, and the vice versa. But
not only that. So the 5G will complement or satellite will complement to 5G wherever there is no 5G coverage, right? So there may be a umbrella satellite coverage already coming to the. So suppose I have a subscription of 5G network, but I can also utilize the satellite in case even devices are to be coming in that sense. So today we don't have a mobile device which can receive a satellite signal except for the GPS. So once those devices would also evolve, so I can have, say, downlink direction broadcast services or any other download services from satellite. For example, if you have a IoT devices spread across geography, and those IoT devices would also require certain update, say firmware update, or that kind of update. So that can come from the satellite, and the 5G, so they can identify and authenticate to the 5G core, and 5G core can communicate to the satellite part, and those download can happen into your device. So that could be one application. A similar application will find for the backhaul also. The satellite can become 5G backhaul in some of the area. So there are a lot of talk going on what all unification will take place. This is in kind of a stage where discussions are going on. So hopefully in a year or two, some specification will come out and we'll be able to identify what all features are being unified.
Broadly, you mean to say that the satellite device identifier will merge with this 5G identifiers also?
Yeah, there will be more category, so type 0, type 1, type 2, so there can be type 3, type 4 and all, right? As far as identities are concerned.
Okay, thank you.
Okay. So let us have a break for 5 minutes. So about, now it's about 4 p.m. So maybe 5 minutes. 4-5 p.m. पे मिलते हैं. Okay, so shall we start?
Yes, sir.
Okay, fine. So the next topic is GUTI, globally unique temporary identifiers. So we have been talking about it. It is a temporary ID, and this is used over radio link, right? So this is only for 3GPP access where we have G node B or 5G RAN, and it is allocated by access and mobility function. AMF allocates GUTI to the UE, and it is an 80-bit long and has got the PLMN. PLMN is nothing but your mobile country code and mobile network code. And then you have AMF ID. AMF will have ID, so that ID. And then you have a temporary number which you allocate, AMF allocates. So this temporary ID is not fixed to a user or a mobile. It is really a temporary number, right? And the temporary number also reassigns. So 5G GUTI is reassigned by AMF at particular under certain specified events. And finally, once a user equipment has got this particular GUTI, it can use it either accessing 5G core through a 3GPP network, that is your G node B, or even from a non-3GPP access is also possible using the same GUTI. Once GUTI is allocated, that is valid for access through 3GPP or non-3GPP, but AMF remains same. The common AMF handle the call, whether the call is coming from G node B or coming from a non-3GPP access. Very good picture which gives breakup of this particular 80-bit ID. So 80-bit ID is broken into two parts. The first part is your AMF identifier, which we call it GUAMI, globally unique AMF ID. Globally unique AMF ID, which is 48-bit, and balance of the 32-bit out of 80 is your temporary mobile subscriber identity that AMF decides, the temporary ID given by the AMF. Now this GUAMI also consists of your mobile country code and mobile network code. So mobile country code is your 12 bits and mobile network code is your 12 bits again. And then 24-bit is for actual AMF identifier. And this also is divided into three parts. One is the AMF region ID. So you divide your coverage into various regions. So you give a region ID. And then set of AMF is called AMF Set ID. And within the set, you point to a particular AMF. We call it AMF pointer. 6-bit here, 10-bit here, and 8-bit here. So total 24-bit for identifying an AMF. So this 5G GUTI, which is of 80-bit, is not used always. So generally it is 5G shortened TIMSI which is used, which is nothing but your AMF set ID, AMF pointer, and this temporary mobile subscriber identifier. So this becomes 48-bit. This is your 48-bit. So whenever customer is within its region, AMF region, so network uses only 48-bit of this GUTI instead of 80-bit GUTI. Any question here or shall I proceed? Okay. So this STIMSI which I talked about is also helping kind of it is becoming more efficient, being a less number of digit. So less load, less overhead, right? So that is the only aspect which is being covered here. Okay, so I think yesterday or day before there was a question that at what different events the new GUTI is allocated by AMF. So these are these. So first is that whenever is the initial registration taking place, after successful registration process, a GUTI is allocated by AMF to the UE. And thereafter UE uses that GUTI as its identifier. The second aspect is that when there is a mobility update, whenever there is a mobility update, that means if the mobile has moved from its area to other area, it does a mobility registration. So at that point of time also a new GUTI is allocated to the user equipment. Next is that whenever there is a periodic registration update, at the defined interval there is an update by the user equipment. So at that point also the new GUTI is allocated by the AMF. And finally, when there is some service request message like paging and all, so at that point of time also the AMF allocates new GUTI to the UE. So these are different events on which new GUTI is allocated. This is a temporary ID given to the user equipment which it uses onto the radio as its identifier. So basically to preserve the privacy. So double. So initially also it is not using the SUPI, it is using the SUCI, but later on after registration it is using the GUTI. Okay, so we'll talk about these identity exchange in a bit detail, and we'll also tell you what are the different security threat which our 2G, 3G and 4G network is having as of now and how 5G has solved that. So here it is. So in our 2G, 3G and 4G network, basically the IMSI, when you send IMSI onto the network, we are sending in a plain text. If somebody is able to intercept the radio, they will be able to, know your IMSI and other informations onto the radio access link. And then once you know that, you can create a fake BTS and try intercepting the user. You can try intercepting the user. So basically that is a kind of a security issue which you have in 2G, 3G and 4G. So this problem was till 4G. Now what was that problem? So if you have certain setup like this, which is available in the market, I see some noise coming. Let me mute everyone. Just see this setup. This is a IMSI catcher. So somebody can write a code and make some hardware, and now you'll be able to catch the IMSI and also intercept the mobile devices. Neither the customer will know nor the operator will know, and somebody will be watching you or somebody will be listening to you, or all your data he can intercept. So this was a problem in 4G. There were certain professional equipment also in the market which you can buy and do interception. These all were illegal kind of interceptions wherein you can act as a fake BTS and intercept any user and user will not come to know. So that was a problem in 2G, 3G and 4G. 5G has solved that problem because in case of a 5G, your SUPI is never transmitted in a plain text onto the air interface. So how it does it, just see this particular picture. That suppose there is an initial registration request. So in this registration request, the user equipment is not sending SUPI, but it is sending the encrypted one, SUCI, which we just discussed. So it goes to AMF. AMF will not be able to decrypt because the private key, corresponding private key is with UDM. So ultimately the request will go to the UDM, that SUCI will reach to the UDM. UDM using the corresponding private key will find out the SUPI, and then this SUPI will go back to the AMF. So now AMF has SUPI. So what it will do is it will create a table. Against this SUPI, it will create some GUTI, globally unique temporary ID, right? And AMF will send that GUTI during the registration accept message. So now UV has got GUTI. So now onwards it will use GUTI in place of SUPI or SUCI, right? So the next time onwards, be it a mobility update, be it any other aspect, it will send the GUTI. And since AMF already has a table mapping of SUPI and GUTI from a previous registration, so its authentication will be successful using the GUTI itself. There can be other scenario that for some reason the GUTI is lost. So what AMF will do that in case the AMF is not having corresponding mapping of SUPI and GUTI, then it will request the user equipment to identify with SUCI. So it will send the SUCI again and the same process will be repeated. So here I can stop and take any question if you have any doubt here. This is very, very important aspect which I told you.
Sir, in that case, in future, when this is GUTI catcher may also come up in future.
So that's why it is changing very frequently, right? So with GUTI you cannot do anything because one, with GUTI you will not be able to identify the user. Secondly, GUTI is changing frequently, so you cannot do that, right?
No, but in GUTI, once it has been captured, in that case, through GUTI, whether this identifier, this ciphering key or something that may be revealed, or
you cannot do anything because one is that the mobile device, the SUPI is required by the network. So earlier what used to do, the fake BTS used to pretend as a UE. So it was, I mean, so whenever there is a requirement, it was able to present the IMSI. But in this case, since the SUPI part is always encrypted, so no, I mean, so earlier also the fraud was, GUTI was there in 4G also, right? So fraud was not happening using or misusing the GUTI. It was happening using the IMSI itself during the initial registration when IMSI is sent. At that point of time, that was being cached, right? So the problem of security was with plain text IMSI, not with the GUTI, because GUTI is changing very frequently, and that is allocated by the UDM, right? Sorry, AMF. So I don't see any issue related to GUTI. And even if it happens, suppose in an IT world, anything can happen. so the standard will find other solution in the next release. Okay, so nothing is foolproof. So in case you feel that something is happening, then perhaps in the next release or next update, people will work towards that. It's a game, right? Between the
and how this how these enforcement and agencies will pitch in for capturing through capturing on radio interface the transaction of information.
Enforcement agencies are not required to capture at radio level because the 5G network architecture has already provision for lawful interception. In case of a lawful interception, all those provisions exist in 5G. So whatever they want to do, whether they want to take IRI or CC, both are possible in 5G network. So as such, lawful interception will not require such kind of arrangement. Okay.
Okay. Okay.
Fine. Okay. So, I mean, we have been talking about how 4G and 5G will interwork, right? So there also, I mean, since 4G and 5G network will coexist, so sometime you are in a 4G coverage, sometime you'll be in a 5G coverage, and suppose you are on a call, so call continuity will also be there. If your data is going on, continuity of that will also be there. So how this GUTI mapping takes place when a mobility from 4G and 5G and 5G from 4G is happening. This is just a picture which you see. So the first case is when a mobile user moves from a 5G network to 4G network. Suppose there is a device in a G node B area, this site somewhere, and it is using a data, that means it already has got that 80-bit GUTI. Let me tell you that in 4G also the number of bit was 80 only. The only difference was definitions of different subparameters were different. So now let us assume that this user is trying to move to the 4G area. So when it moves to the 4G area, it has to follow the 4G protocols, right? It has to follow the 4G protocols. So while sending the GUTI to MME now, mobility management equipment, what it will do is it will map this 80-bit as 80-bit of 4G, 80-bit of 4G GUTI. Yes, it will do a mapping, simple mapping, and send it to MME. Now what MME will do, because it is handover, so there is an interface between MME and AMF, so it will know that it's a handover case. So it will again convert back. Now it is receiving the kind of a 4G GUTI, the 5G GUTI looking as 4G GUTI. So it will convert back into 5G GUTI and send it to the AMF. Now AMF will understand the GUTI and it will send all the related information, right, which it is having related to this user, that we call it context exchange, and this handover takes place. Reverse example. In that case, your device is in 4G network and moving to 5G network. Exactly reverse thing will happen. So this is a conversion that here we had MCC, MNC, AMF region code, AMF set ID and AMF pointer ID. This is written wrongly. This is pointer ID.
Excuse me, sir.
Yeah.
Sir, this is conversion from 4G to 3G. What happens if the customer or the users having a 3G, 2G?
So this is 5G, 4G. There is no interworking with 3G in this case. Roaming will not, I mean, so continuity of roaming will not be there with 3G. So it's only 4G and 5G. Okay.
So the 2G or 3G user cannot be forward into the 5G network.
Even 4G user cannot use the 5G network unless you have a 5G subscription. You cannot be in 5G network. So your 5G device will have all chipset, 5G, 4G, 3G, 2G. So basically, if you have say 4G connection today, LT connection, your device will not work in 5G network. If you have 5G, it will work in 4G. So it's different. Okay.
Okay, sir.
So, but as far as continuity of service, that means you are in a call and you can roam into 4G network, come back into 5G network. This is between 4G and 5G only, not with 3G. 3G you can latch and use the data if you have a subscription, right? If your device is 5G, it will support 3G. Wherever there is no 4G, 5G coverage, you'll be able to latch and do it. But service continuity between 5G and 3G will not be there. Is it clear?
Yes, sir.
Okay. Okay. So now there is a concept of RNTI, Radio Network Temporary Identifier. So there are a lot of information exchange, control plane information exchange, which happens between the user equipment and the radio network. And many a times the user equipment has to be identified, or group of user equipment has to be identified onto the radio. So RNTI is used for different purpose. I'll give you some this table. So this RNTI in itself is a big session, right? So here in one slide, I just wanted to tell you that there are many type of RNTI. For example, for paging in mobile, there's a concept of paging, or system information change notification. So this is some kind of RNTI. We call it PRNTI. Then you have SI RNTI for broadcast of system information. Then you have random access. Random access is a process wherein uplink synchronization takes place. So for that purpose, during that process, the ID used by user equipment is called RA RNTI, and so on. So there are temporary CRNTI, there are MCS RNTI. So a lot of this RNTI is used in 5G. So in case you are interested, you can read this particular document. It gives a lot of detail. So in my session, I'm not covering much in detail. I was talking about UV radio capability in yesterday session. So what is an UV radio capability as far as our this identity session is concerned? So basically, what is UV radio capability? We know that UV supports now in 5G. There can be different bands supported by a device, right? So it's a capability of UV. It can support one band, it can support two band, it can support multiple band, right? So these UV capabilities are written into the UV device itself, or sometimes the UV capability can be assigned even by the network operator. So let us see how the identifier looks like. So this is a kind of identifier. This box is an identifier. So basically, this is the actual identifier, RCI, that is radio configuration identifier, which gives that which frequency band it supports or which power class it supports. The rest are kind of information like TF is your type, whether it is manufacturer assigned or whether it's assigned by the network. This is your vendor ID. If it is assigned by manufacturer, then what is the vendor ID? And this is the version in case network is assigning that. So this is just a kind of a radio capability, which during the control signaling exchange with G node B and core, these are known to the core network, and accordingly it treats. Now we have come to the network identifier. So up till now we have been talking about user identifier. Now let us talk about the network identifier. So the first thing will be our NR cell global identifier, the G node B which we have, how do we globally identify? Then there is a concept of tracking area. And then for slice and all, we have single network slice selection assistance information, that is S-NSSAI. So one by one we'll go through. So this is identity for our G node B. We call it new radio cell global identity. So this is nothing but your MCC, MNC, and NCI, right? That is NCI is new radio cell ID. So for every cell there is an ID, and this will consist of your G node B ID and your cell ID. And there are certain bits which is written here. Next is tracking area identifier. Can someone tell me what is tracking area in case you are working in mobile or worked in mobile 2G, 3G, you may be knowing the tracking area concept. Any one of you? You can say yes, no, so that I proceed. Any of you can answer what is tracking area?
Identify the user location.
I think it is VLR.
Basically, this is a group of cells where paging happens for locating the subscriber when any incoming call is there.
Very right, very right. So basically, it's a cluster of the cells. Here you see the yellow color is your tracking areas. These are various cells. Defined as tracking area. So this is your tracking area 1. Similarly, the green one is your tracking area 2, tracking area 3, and tracking area 4. So I was just when I was taking 5G core session, I explained you that AMF knows location of the user, either the cell ID, which cell it is located, or at least the tracking area, So where paging is done, right? So whenever suppose there is some incoming data for a user, the user has to be paged. So that paging happens in the tracking area generally. I'll talk about some exception in the next slide, but in the tracking area. So every tracking area has an ID, identifier. What is that? So that is your mobile country code, mobile network code, and then your 5GS tracking area code. So you can identify a tracking area. System identifies. This is a very, very new concept in 5G. It was not there in 4G. I seek your attention that this concept was, Himanshu is saying that it will be pasted in all TI in the TI list. Yeah. Okay. So just look at this registration area concept. What is registration area concept in 5G? And it was not there in 4G. So it is set of tracking area. So here I am showing tracking area 1, tracking area 2, and tracking area 3. So certain set of tracking area will be called registration area, right? What is that? So let us take an example of this bus. So suppose some IoT sensor is installed in this bus, and bus every day, moves from one place to other place and comes back. Its route is fixed, right? So basically, the normal location of the bus in a day is this route going and coming back. So for this bus, the registration area will be combination of TA1, TA2, and TA3 because it is running on a standard route. So 5G system, we can define registration area for this bus IoT sensor in this bus as a registration area. So now instead of paging being done in a tracking area, in 5G paging will be done in a registration area, and this registration area you can configure in multiple manner in 5G core, right? So basically, whatever is the mobility pattern of an UV. For example, suppose I go to office Delhi from Ghaziabad. So my route every day will be from my home to my office in Delhi and come back to my home. So for me, my registration area can be defined as combination of TS which is falling in my route, right? So basically it reflects mobility pattern of the UV. It's a new concept in 5G. So for every device, you can have a unique registration area specific to a UV. So what is the benefit? Now that whenever I am in my registration area, yeah, so I mean Himanshu, those were very, very hard list of TAI. So Himanshu has given some comment. That's very, very hard list of TAI tracking area for an user. Here I'm talking about based on your mobility, the system can actually define the registration area for a particular user. That is one way of doing it. The second way of doing it is that during the provisioning, I can define registration area for an user if I know the mobility pattern. So either the 5G system will learn or it will be configured. So since the paging requirement is getting reduced, the mobility update which IoT sensor and all have to do is getting reduced. So there is a lot of signaling overhead being reduced and also the power efficiency for IoT kind of devices. Okay, so I'll stop here for any question because Himanshu was writing. So if you want to say something, Himanshu, please go ahead. Himanshu Gupta, do you have to say anything? Write in chat box or speak out. Okay, let me proceed. Now this is for network slice. There is a concept of network slice selection assistance information. So basically slice type and slice differentiator. This is an ID. So SST value can be 1 for EMBB, 2 for URLLC, 3 for massive IoT, which is defined in the standard. And going forward, you can add to this list. So this yesterday we talked about this, how this network slice selection function based on S-NSSAI will assist AMF to select a appropriate slice. This is an example you can just see. This is an example of network slice. Suppose this is slice 1, this is slice 2. So slice 1 is going to data network 1, slice 2 to data network 2. The important point to note here is that there will be certain common network function for all the slices. There is a possibility of having common network functions. These are common NF, these are specific NF. And as of now, till release 16, a user can access 8 slices simultaneously, maximum 8 slices simultaneously. Although network can have n number of slices, but an user can access simultaneously, I'm saying, 8 slices. And this limitation is coming because of some signaling message which can have only 8 values. Okay, so we are coming to almost the last. So UV identity, network identity we have covered. Now we will go to the core. So all the core network functions have identity called FQDN, fully qualified. Himanshu, I have answered your question. Registration area is completely different than TAI as it is dynamic or configurable. Okay, so 5G core frequency, fully qualified domains name. So for example, home network domain itself. So to identify 5G home network domain, so you will write 5gc.mnc, whatever the number, .mcc, whatever the number, .3gpp network.org. If suppose MNC is 12 and MCC is 404, so it becomes 5GC MNC 012 MCC 404.3GPP network.org. So this is a kind of a fully qualified domain name for home network. Suppose there is a private 5G network. So the private 5G network is allocated a network ID. So we'll just add network ID like this. 5GC, an ID, network ID, and rest will remain same as was there in the home network domain mentioned here. So if suppose an ID is this allocated by regulator or government, so it will be 5GC, then an ID, and rest is a same. Home network domain is given a fully qualified domain name. Now for network repository function, as we talked yesterday that this is repository of information about all other network function. So, so any NF which is installed, it has to register with NRF, and other NF can discover it through NRF. So that means provisioning is there in the. So now many a times other network function have to at least know the fully qualified domain name of NRF, because it has to access NRF to get address of other NF, but how to access NRF itself. So they will be able to self-construct NRF FQDN being in very, very standard configuration. So within PLMN, this is the fully qualified domain name of NRF, and it will be pre-configured during installation itself. The fully qualified domain name of NRF will be configured for each network function so that it is able to access NRF. Right? So, so while you actually query NRF, this is a kind of URI you use, HTTPS kind of a URI you use to access the NRF, or for that matter any other network function. Okay, now how do we have fully qualified domain name of AMF? So it is like AMF ID.amf.5gc, rest are same. So AMF ID.amf. And in case it is private network, then you have to add the NID in between. It's a very, very simple concept. Once you understand one domain, then you can really guess the other one. So for example, you have AMF set, then you have particular AMF instance. So set can also have a fully qualified domain name, and instance can also have a particular domain name. Similarly, SMF can also have a set fully qualified domain name. It is very, very obvious. You can read this. It's very straightforward. You can have fully qualified domain name of each of the core network function. So with this, my slides are over. We can have a discussion, free flowing discussion if you want. I request everyone to open your video and have